Hello. So we are going to introduce you today the benefits of GitOps and how we are implementing GitOps within the Sylva project initiative. And when we will have a wonderful demo to show that kind of benefits. And we're just starting to present ourselves. So, Cedric, who are you?
Hello, everyone. Great to be here. So I'm Cedric Yhuel from Oracle Communications. And my role is to support Orange and other French customers in deploying and making the most of our 5G network functions.
Hello. So let me introduce myself. So I'm Guillaume Nevicato. I'm the Telco Cloud product manager for Orange. And I have also a role within the Sylva community as I am co-chairman.
Hello everybody, I'm Sylvain Desbureaux, so I work at Orange too, and my goal in Orange is to provide all the tooling needed for people to deploy and handle the life cycle of the CNFs.
Okay, so we are here to speak about GitOps. So are you all aware what are the benefits of GitOps around these rooms? Okay, who have already deployed GitOps at large scale in production? Yeah, so it's progressing year on year. So just start about the problem statement we want to address today. So we see that in legacy way to manage configuration, we used to have lots of scripts. If you want to provision the cloud infrastructure, if you want to upgrade or to limit the impact of services when you want to upgrade your network functions, or if you want also to deploy your network functions in many different sites. So we have measured this within Orange, for example, for the CDN use cases, the content delivery network. We have seen that for us, we have to use 20,000 lines of Ansible code in an imperative way to manage this whole lifecycle management. And when we are adopting cloud-native patterns, GitOps way, it's less than 1,000 of lines. So it's really a game changer for us in terms of efficiency. Another issue, when my persona is I'm joining a new DevOps team on Telco Cloud, and I have to manage 100 sites. And my actual team is using lots of Terraform code and Ansible script to provision all this infrastructure. We are a very friendly team, but with lots of oral tradition, you know. And the matter is that many things happen since the day one. So, no, I can guarantee that what I have deployed in terms of operating system, in terms of Kubernetes configuration, in terms of network function configuration in all my sites is coherent. So we have this big question now. And my last persona, no, I am a manager, network operational senior manager. I've got, for each network function, I've got a specific tooling. And for each network function, I've got also its own cloud solution. So, my challenge, I can build one efficient team to deal with that in terms of skills. And I let the floor to Cedric to give some solution about this.
Thank you, Guillaume. As I said, I work for a telco vendor, so in the next few slides I'll try and give you the telco vendor perspective on lifecycle management. And in particular, I'll compare the traditional approach with the GitOps-based lifecycle management. And finally, I'll open on autonomous networks a little bit. So on this slide, you can see some attributes of the legacy or traditional lifecycle management approach. When I talk about lifecycle operation, I'm talking about many things, in fact. It can go from installation, deinstallation, upgrade, downgrade, resizing, or even reconfiguration of a telco workload. So these operations traditionally are done using the imperative model using either local or remote access, and can vary in terms of automation. They usually involve proprietary processes, proprietary tools. So we end up with what I call a supplier tech silo, with bespoke tools just dedicated for lifecycle management that have their own lifecycle to manage. And all this introduces a kind of technical vendor lock-in. And it can also be go with, depending on the operation, with some customer-specific artifacts, even hardware retrofits, remote staging. So to summarize, this approach, even if it's not a bad one, depends on the context and the goals, it's usually quite specific, proprietary, and therefore usually a bit costly for the service provider. So now let's talk about GitOps-based lifecycle management. On the left, you can see a very high-level depiction of the workflow we've been using at Orange, with on the top the different artifacts, configuration, infrastructure as code, which are pushed onto the Git repository. Then these artifacts are regularly reconciled with the target Kubernetes cluster using a tool such as Flux. And then this triggers some controllers, customizations, in order to implement those changes to reconcile the state of the telco workload with these intents. By the way, these workloads can run either on the same cluster or, in our case, in a remote cluster. So this way of operating is declarative, of course, done remotely. It's an open way of doing things, so therefore it becomes vendor agnostic. And no supplier tech silo is required. We can do it all with standard CNCF tools, even though here and there you may have some, let's say, supplier-provided facilitators, but always in the context of this ecosystem. And another interesting item I wanted to touch on is the supplier role and responsibility in this new model. When in the previous slide you had, let's say, a model where the supplier was carrying most of the responsibility and the tasks, in this model you really need to have a discussion between two players, the supplier, of course, providing the workload, the upgrade package, the charts, and the GitOps team, who will handle the logistic part. And finally, a few words about autonomous networks, and more specifically, what does GitOps bring to this initiative. So GitOps has some really interesting attributes. First of all, it's, let's say, encouraging the everything as code approach, which introduces a common language for the different players throughout the network domains, network technologies, vendors, which make it easier to troubleshoot, to maintain, and to store, in fact. Next thing that is related is the fact that this process involves reconciliation loops, which is the way, as you know, Kubernetes operates. And Kubernetes itself is an autonomous system. So this way of doing things is, let's say, it's field-proven, and especially in the context of very complex autonomous system. The next thing I wanted to discuss is how the elements access the data. So Git repository brings some data compartmentalization and change validation process, which enables a model where every subsystem can use only the data it is entitled to on a need-to-know basis. And finally, and most importantly for me, is the decentralization aspect that is enabled by GitOps, where instead of having massively complex networks, you are able naturally to divide this system into much smaller and manageable subsystems that will all be autonomous, which will use different level of network abstraction and granularity. And in this model, depicted on the left, you would have on the top some business intents that are slowly reformulated, decomposed by the different subsystems in the stack until you reach network-level intents that can be consumed by the network elements, even the cloud infrastructure. So to summarize, I'd say that GitOps, without being the golden bullet, introduces a set of processes and tools that are making the move to autonomous network more straightforward. Thank you.
So how Sylva can help to implement GitOps? So in fact, we've got two different work groups within Sylva. The first one is dedicated to develop a Sylva stack, and there we are implementing a GitOps way to manage the lifecycle management of Kubernetes cluster, of infrastructure. And so we developed it since the beginning of the project. And the second part is on the network functions layer. We launched this year a second work group dedicated on this, on sharing the good practices, and now we are studying if we can do more with a reference implementation with other partners. And so now where we are in the Sylva adoption to support these two work groups, so just to have a quick view on this, and we will have a dedicated meeting tomorrow on Birds of Feather to present Sylva, so if you want to know more, join us. But just to have a quick view, now we have almost 60 developers around Sylva. We have got a very active followers on the Slack. We've got now 29 companies involved in the project with 12 financial sponsors. And we are in production with the Sylva stack with more than 1 year. And we have 15 network functions that have been validated in our validation center of Sylva. We've got 5 validation centers, 5 platforms opened for the onboarding of network functions, where we are using more and more GitOps process, as you can guess. And just here is the map of the different logos, where we have around the network functions and applications, operators, and IT vendors involved in the project. And next year, I will need a full slide to have the logos, because it's really growing fastly.
Okay. Thank you. So let's move a little bit to the demo. So what I wanted to depict is to see how it goes when you are on a pure GitOps way of life. So a GitOps native Kubernetes cluster, so using Sylva, and cloud native network functions that are able to be deployed using GitOps concepts. So first, I will explain where we are before the demo, so what we have done before arriving to what we will show. So we have an OpenStack cluster with different networks, external networks, and we have obviously Git repositories. So the guy in the middle represents the different manual actions that we have done at first. So there are a few manual actions, there are actually only 3, and mainly to bootstrap everything before starting. So the first thing that we have done is that we have used the Sylva CLI to deploy, first to create a network and a tenant inside OpenStack by hand, but you can use Terraform and Sylva, whatever you want, but yeah, I did it by hand. And then I use Sylva CTL to deploy the management cluster. Sylva has this concept of a management cluster where from this management cluster you can deploy as many workload cluster where you will have your workload, as the name stands, almost everywhere. So this is a manual step. Of course, it's a very simple one, but you have to start somewhere before the magic happens. And the last stuff that we have done, so you see that in the Sylva cluster, we have a Flux instance, or a GitOps engine, and we need to give to this GitOps instance the seed, the first Git repository that will allow us to deploy everything we want. So I give to Flux the seeds. The seeds start to look and to deploy everything that we need. So the first thing that we have done is to automatically, using a Terraform controller, a tenant and networks into OpenStack. But of course, if you have any APIs-based stuff, you could use that. Here for us, it was the simplest. Then we ask Sylva, and using ClusterAPI, to deploy a cluster for workloads. And once the cluster is deployed, we also automatically deploy a database for the stateful part of the network function. The Oracle NRF, which is the network function. And on top of that, we have also deployed an internal tool, which is a tester for this particular network function. So it's not doing some simple health check, it's actually an NRF for those who don't know, so almost everybody, I guess, except the 5G people, is should be a DNS, but it's not a DNS. So you can add stuff in it, remove stuff in it, and it's fully APIs. So what the tester does is, can I reach the NRF? Can I add a new network function into this NRF? Can I remove it? Can I subscribe to else status of this network function? So that's mainly what we will do. And we will test continuously our NRF to see that everything works in all the time. So let's move to the demo. So I'm really sorry, it's not a real demo. I hate that, but it will be a video demo because it does last 1 hour. It's not that long, but it's a bit long for today. For those who have issues with sleeping and stuff like that, who like French movies without real scenario and so on, I will upload it as a full 1 hour video so you can sleep well or stuff like that. But here you will have the short version. The scenario is not very better, but at least it won't take that long. So I try to show all the moving pieces that we have together. I'm sorry. I hope it's relatively clear. So let me start. Yes. So the first thing that we will do is that we will perform an upgrade of the Kubernetes cluster. So first, before starting everything, on top of the screen, you will see the different workloads running on the cluster. On the bottom, so you see here that we are using OpenStack. So it's based on Ubuntu, this workload. We are using a specific version. Everything is done using Sylva. This part, so sometimes it's too fast for me. This part is a test. So you see that everything is green. We are launching one test every 30 seconds, and the test lasts roughly 10 seconds. So I will not say that it will be hitless, but at least we will test as much as possible this NRF function. And as I said, on the bottom that we still see a little bit here, we will see the different nodes that we have on the cluster. So here it shows that everything is working as expected because we have a brilliant network function from our friends. And what I will do a merge request. So again, it's GitOps, so that what you do is you push stuff on Git. And what I will want to do is I will want to change two things. So my administrator says that we don't use Ubuntu anymore, but we want to use OpenSUSE. And we need to move from 129 version to 130. So that's exactly what we are seeing here. You see that I am using a lot of customization stuff that here we see that as an environment file, but it will be translated into a YAML config map where we ask the change from Ubuntu to OpenSUSE and from 129 to 130. So it's GitOps, so you, someone else should review what you are doing, should approve, should you merge. And then GitOps engine, he will wait, and sometimes he will check if he has to make some modification. Of course, here we will skip this part, and a few minutes later, we will see that the work would redo. So Sylva has like for deploying CNF is not just deploying a new version of the cluster. He will check if he has the image. If he doesn't have the image, he will download them. He will do a lot of pre-work before the actual upgrade. And so that's why it takes some time. Here we see that a new node has appeared somewhere here, so it's very small here. And when it's really ready, we see that ClusterAPI decides to drain an old node, and when it's drained, we will see it will be removed. In parallel, we have the same stuff for the control plane. And if you look on the right part, you see that we have some tests, and we see that the tests are still passing all the time. You will see that here. Why? Because the network function from Oracle is cloud native in sense of you have several replicas, so that means that when we are draining a node, you can, for a short time, have less replica of your deployment, but it still works thanks to Kubernetes load balancing of the services. So that's what we are seeing here, and we will see that we will do that for every node. So again, what's important is not the speed. Of course, it's very fast, because at the end, it will take 30 minutes to upgrade the cluster. But what is very important is that you can replicate all the time. It's very consistent. You ask, your intent is to have this kind of version of the cluster, and ClusterAPI, Sylva Kubernetes will deliver you at the end of it, or will try everything to make it work. And GitOps will check these new changes to put them into into your cluster. So that means that as a ops point of view, it's very interesting because it's very easy and it's very simple to control, and you know exactly what you have in your cluster. This morning there were edge discussion also here, and that was one of the points also. If you deploy one thing, it's very easy and you can do manual stuff, but when you have several clusters, several workloads and so on, you have to be sure of what you are doing. And GitOps is really a way to do that. And so that's where we see that we have these new virtual machines that are spawning and the old ones are deleted. And all of that, nobody is doing anything. I was just screencasting my laptop. I was not doing anything. This is really what provides GitOps, ClusterAPI, and Sylva ecosystem. So it's very easy, and it works. So if we, every 5 minutes, we will have a new node, as I said. So we have 5 nodes workload cluster, so 25 minutes roughly. So it's quite fast, again, but don't consider this as fast the most important. The very most important is that the reproducibility of that. And if it doesn't work the first time, it will retry and so on. So that's where the magic happens. It's not really on the speed, but really on the reproducibility of the stuff. And so we see that at the end, so maybe I will skip a little bit. Yeah, we have upgraded our cluster. And so if we look at now our workloads, we see that everything, just as the Sylva units, so M release for those who knows and stuff like that, everything is good. We see that our tests are still passing. We see that we have moved from Ubuntu 1.29 to OpenSUSE 1.30, still on RK2, but still, and we see that everything is green. So all our tests are passed without any issue. And again, we have decoupled also the lifecycle of the CNF and the lifecycle of the Kubernetes. So it's very important also. That means that you can have a different roadmap and not have to synchronize all your upgrades at the same time. Of course, we can also upgrade the CNF. Here we see that everything is working. So I will move a little bit because I'm talking too much, I guess. And we see that everything is working. So let me find, now we will upgrade the CNF. It's the same way. GitOps, what you mean, a merge request, you change the version. Here it's a very simple version. We are changing from the one major version to one of its fixed. So you can think CVE, stuff like that, you need to change. And the same stuff will happen. So it's M release, so you have pre-hook, post-hook from Oracle. Again, I will go fast because you have understood the story. If you have a cloud-native network function, you will, you should be able to have as little as disruption as possible, even no disruption if it's possible. Of course, if you have a data plane stuff, it may be a bit more tricky, but here, for control plane stuff, we have no disruption at all. So that's why I try to show you, and we see that now we have moved to the latest version of this network function without any hassle. Again, it's reproducible. Inside Orange, we are deploying a lot of this network function in a lot of different countries. And for us, it's also very important to have this way to be deployed all the time the same way. Again, reproducibility, to be homogeneous across our different networks, to have the same way to deploy is very, very important for us. To, of course, to have a good network and a good experience. So here you see that everything is working. So actually there is one test failed. It happens, but that's okay. So I move to the next slide. So the key takeaway, I'm stressing that because at first I was more thinking about speed than anything else, but it's not that important. The consistency is important. You have no manual workaround that you have to do for the next upgrade. This is something important. As he said, the oral tradition that we have in our networks could be very huge, and sometimes if someone is not there, it could be very complex to troubleshoot because he had done something and nobody knows that. We declare the declaration, everything is in Git, so you declare your intent, and the intent must work, of course, so that means that we have to work together with our CNF vendors to have something that is possible, but there are a lot of tricks and tips and tricks that you can use with Flux or any other GitOps engine that allows you also to make these specific steps before or after the upgrade very easily. And again, as I said, we have completely decoupled the life cycle of Kubernetes and the CNF. That doesn't mean that the CNF could accept any version of Kubernetes, or Kubernetes can accept any version of the CNF, but we can change them at a slightly different pace without any issue. So I will leave you the key takeaway.
Yeah, thanks. So, yeah, we just show with the insights of Cedric and the demo of that you just shared that GitOps, in fact, makes your DevOps life easier. And no, you are not obliged to define your target, and you will rely on orchestration, and so it's better than relying on long script, as we shared before. It's very important to have this common GitOps tooling solution to have efficient operation. And again, if you thought about my senior manager with lots of tooling different for each network functions, yeah, we are this with common tooling. So it's much more easily than a siloed network approach. And last, just coming back on the CNCF survey about GitOps, concerning the objective of GitOps. So you have the answer here, and definitely what we shared to you today was in line with the different results. So as the last point, if you have any interest to test GitOps approach, to adopt at scale, here we are with the Sylva community to support this, and you'll find a slide, you've got the QR code and so on, so you'll have the different work group where we can get involved, and you've got the mails of the different leaders of this topic on the Sylva community. Many thanks. Yeah, so I think we've got 5 minutes for a question or two. No, but we are here. So we've got lots of Sylva experts here. So during the break, don't hesitate to grab us to have sessions.
Thank you.